Welcome to PON Resiliency, the third video in the TEL Labs Optical LAN System Architecture and Application series. This video explores the exceptional resiliency of the optical LAN system, highlighting how its PON architecture ensures robust performance and reliability. The topics covered in this video will be a discussion on the reliability advantages of fiber optics, a list of carrier class features supported by the optical LAN system, and an explanation of how PON protection eliminates single points of failure in optical LAN. Passive optical networks are renowned for their exceptional resiliency, making them a cornerstone of modern enterprise LANs. By utilizing passive components, such as optical splitters and fiber optic cables, PONs eliminate the need for active, power-dependent equipment between the network core and end user, significantly reducing points of failure. This inherent simplicity enhances their reliability, enabling consistent, high-speed data transmission even in challenging conditions. Optical LAN relies primarily on fiber optic cables, which transmit data via light signals. Unlike copper cables, fiber is immune to interference from electrical devices, power lines, or radio signals, reducing signal degradation and ensuring consistent performance. Fiber optic cables have significantly lower signal loss over long distances compared to copper cables. This allows optical LAN to maintain strong, reliable connections over extended ranges without the need for signal boosters or repeaters. Bit error rates are minimized by employing transmission standards for the PON fiber interface. The TEL Labs optical LAN system uses forward error correction over up to 20 kilometers between OLT and ONT to optimize signal reliability. Optical LAN supports much higher bandwidths, enabling it to handle large volumes of data with minimal latency. This reduces network congestion and ensures reliable performance, even as demand grows. Additionally, this can be achieved over the same fiber optic infrastructure, eliminating the need to upgrade cabling when higher bandwidths are deployed. Optical LAN relies on passive components like optical splitters, which don't require power or active cooling. This reduces points of failure. This is a clear advantage compared to traditional LAN, which depends on powered switches and other active equipment prone to outages or malfunctions. Optical LAN uses a point-to-multipoint architecture, reducing the number of components and connections needed. Fewer components means fewer potential failure points, enhancing overall reliability. Fiber optic cables are more durable and resistant to environmental factors like moisture, temperature, fluctuations, and corrosion, unlike copper cables, which can degrade over time, leading to connectivity issues. The TEL Labs OLT, built with a carrier class design, includes redundant systems to minimize service disruptions from failures and enable maintenance like card replacements or upgrades with little to no impact on service. Characteristics of the TEL Labs optical LAN system that contribute to this resiliency are redundant ESUs with redundant backplane transport to each PON card slot, redundant power inputs, hot swappable cards, as well as high quality industrially hardened components. PON protection groups can be created to deliver uninterrupted service to the PON splitter by providing a primary and a secondary PON port connection. This will provide a protection situation for the PON port should a failure arise. PON protection groups protect against fiber span failure, PON transceiver failure, PON card failure, OLT failure, and OLT isolation. Type B protection makes use of a splitter which allows two PON inputs on the OLT side of the circuit. This pair of PON interfaces are considered a PON protection group or PPG with a primary and secondary interface. During normal operation, a primary PON port controls and provides connectivity to the ONT group. The standby PON port listens to the group and becomes the primary when it detects a failure on the PON port. Detection of a PON failure in switch takes less than 5 seconds. Along with PON failure, the PON protection algorithm can detect an uplink failure from the primary OLT. If the primary OLT becomes isolated on the network, all PON ports that are enabled for path protection will switch to the secondary PON. Intra-OLT PON protection is when Type B PON protection is implemented on two ports on different OLTs. This is the preferred configuration for reliability reasons and is an option recommended by TELABS. Intra-OLT PON protection is a PON protection group on two ports on different PON cards within the same OLT. This is typically used for cost savings. It should be noted that in this configuration, some OLT hardware in the path is not redundant. While no messaging is required for PON protection switches to occur, it is beneficial to communicate status information from the primary to the secondary PON to speed up switches and minimize service disruption. Outages of up to 1 minute can occur if no sync channel is present and the system blindly switches as all services must be reconfigured. With the sync channel present and sufficient time to sync, the two sides will have the same configuration and switches will be in the 1 to 5 second range. This concludes this video. In it, we have covered a discussion on the reliability advantages of fiber optics, a list of carrier class features supported by the Optical LAN system, and an explanation of the PON protection scheme.